Hello, I am Sadish Kumar from Manipal Academy of Higher Education. Today in this episode, I wish to bring your attention to the optical effects of sunlight while traveling through the atmosphere. So, this talk essentially consists of the importance of solar radiation and how does it transfer through the atmosphere and what are the optical effects which we are observing in our daily life. Here we can see that sun is the primary source of energy during daytime and all planets are moving around the sun, of which earth is one of the planets, and earth intercepts 0.005% of the total energy from the sun, and the solar radiation which falls on the surface of the earth can be classified as 9% of ultraviolet radiation, 45% of visible which induces visual perception, and 46% of infrared. Infrared means it is the heating effect. Now, the ultraviolet radiation, we can see that they can be classified into three different parts. One is UVA and another UVB and the last one is UVC, but UVC is much higher than UVB, and UVB only some part of the light, some part of the energy will be falling on the surface of the earth, while UVA is completely absorbed by the atmosphere. Now, we have visible light about 44%, infrared 48% and ultraviolet about 7%. Now, we can see that this is the actual situation. Light is falling on the surface of the earth and we have a solar spectrum, means the different colors. When sunlight is allowed to pass through a prism, you know that it will be split into different colors, which is known as dispersion. Just like that, if we plot a graph between the wavelength and the intensity, we can see that the maximum wavelength comes to about 500 or 600 nanometers, which is yellow in color. That is the reason why sunlight appears yellow in color. And at the same time, what happens is when sunlight falls on the surface of the earth, earth gets heated up. When earth gets heated up, it produces infrared radiation, that is known as heat. So, any body when it is energized will be heated up and that heat will be radiated into different directions. So, it is applicable to earth as well. Now, if we can see that earth is not stationary, earth is moving around the sun. So, that we have different seasons, because when earth moves away from the sun, the amount of intensity, solar radiation intensity falling on the surface will be less, while if the earth comes very close to the sun, the intensity will be more. So, that this is the reason why we can classify this movement of the earth which results different seasons. Now, this is the picture in which we have different stages, of which we have equinoxes. Equinoxes means equal days and equal nights. Equal days and equal nights means we have March 21st and September 23rd, in which we have the day and nights are equal, while we have another two situations in which December 22nd and June 22nd, in which the duration of the day and night are different. They are known as solstices. Now, this is the actual situation. Light, if this is considered to be the earth's surface, light is falling. Here along the equator side, light is falling normally, but in the polar side, light is falling in a slanted way. So, that intensity of light will be less on the poles and intensity will be very high at the equator. That is why equator is always hot. Now, we can see that when light travels normally, the spot size is less, while when the light is slanting, the spot size is large. Likewise, when sun is just above the top in the noon time, we can classify this as high sun, so that the intensity is very high, but in the morning and evening sun is in the east and west, therefore, they are known as low sun, therefore, the intensity is less. Now, this is the mathematical equation, means when light is falling normally we have 342 watts per meter square, while when it is landing at an angle of 45 degrees, the amount of energy will be, or amount of power will be 242 watts per meter square, therefore, it is less. So, this is the reason why there is a differential heating of tropics or equator region as well as polar region. This differential heating is responsible for producing the change in climate along the surface of the earth. Now, we can calculate the surface temperature of the earth with and without the atmosphere. Atmosphere means it is a gaseous envelope, so that if we calculate the temperature of the earth without the atmosphere, means it is minus 18 degrees centigrade, that means it is very cold. But the presence of the atmosphere, which makes the earth's surface warm, therefore, the temperature becomes 15 degrees centigrade. So, this is otherwise classified as greenhouse effect. So, greenhouse effect causes the earth's surface warmer. Now, this is the solar constant. Solar constant means the amount of energy, solar energy falling on unit area of the surface of the earth. Now, if you calculate this, we can see that it is about 1366 watts per meter square, which is otherwise known as solar constant. It is only an average value, it is not an absolute value. Now, from this one we can calculate the temperature of the earth is 255 degree Kelvin, means it is less than 0 degree centigrade. Now, as I have already pointed out the fact that there is a differential heating in the on the surface of the earth, the equator receives more intense energy while poles receives less amount of energy. We have this graph, means the amount of radiation falling on the earth will be maximum at the equator region and minimum at the polar region. So, that equator absorbs maximum amount of energy, so that it radiates more amount of heat in the outway. That is known as outgoing long wave radiation, that is the amount of heat which is radiating from the surface of the earth. Therefore, there is a change in the outgoing radiation. In the equator side, that means from 37 degrees north to 37 degrees south, excess amount of heat energy will be radiated, while in the polar region, as south pole as well as north pole, there is a deficit, and this in turn produces seasons on the surface of the earth. Now, when solar radiation comes onto the surface, there are two types of radiation. One is the direct radiation which is falling on the surface, and another is diffuse radiation. Diffuse radiation means light is scattered while it is coming to the surface of the earth through the clouds as well as dust particles. Therefore, the total radiation is the sum of direct radiation as well as diffused radiation. Now, this is the short wave radiation which we have already mentioned, and the temperature of the sun is about 6000 Kelvin. So, that this is the black body spectrum of that. Now, if you consider the solar map of India, means the amount of solar energy received, if you calculate at each and every point on the Indian region, we can see that northern part of India is more prone to the solar intensity, especially this is Thar desert in Rajasthan, and this especially Tamil Nadu. So, these areas are more prone, while in this western part of India the amount of solar radiation is less. Now, when this long wave radiation is going to the outer space, this we can see that there are so many trace constituents present in the atmosphere like carbon dioxide, ozone, and all other gases, and these gases will absorb this infrared radiation which is going out from the surface, which as a result this absorption results greenhouse effect. So, without the presence of these gases, the temperature of the earth would have been much lower, while the presence of these species or gases confirms the hotness of this planet. Now, this is the fate of solar radiation. The incoming solar radiation, a part of it will be absorbed by ozone layer, which is at a height of 60 kilometers from the surface of the earth, and we have dust particles in the atmosphere due to anthropogenic activities and industrial activities. So, light is getting scattered by the aerosols or the dust or clouds. Therefore, there is a substantial division of the solar energy which is reaching on the surface. Some part will be reflected, some part will be scattered, and some part will be absorbed on the surface. Now, this is a device which measures the total solar radiation, which is known as pyrheliometer. Pyr means temperature, helio means sun. Therefore, actually it measures the total amount of solar radiation which reaches on a particular location. Now, we have different gas species present in the atmosphere, and these gas species or gases can take energy while vibrating as well as rotating, and by their movement, that is known as translation. Therefore, these gases will absorb energy, and these gases, the energy content of these gases will increase, which in turn can produce the greenhouse effect. Now, this is a nutshell of the various optical processes which are happening in the atmosphere. The first one is the reflection. Actually, we know when light is falling on a mirror, part of the energy will be getting retraced back, which is known as reflection, and another is refraction. When refraction is mainly due to the change in refractive index, and another is scattering. When light is allowed to pass through dust particles or gas molecules, it undergoes scattering, and there is another property as well, as which is known as diffraction. Therefore, these are the main 4 different processes which are happening when light is allowed to pass through the atmosphere, of which the common thing is that the commonly observed commonly observed effect in the atmosphere is rainbow, which is very common. When during rainy days, we can see that atmosphere contains a colorful band in a circular shape, which is known as a rainbow, and this rainbow is previously used to predict the rain and its intensity. Now, actually what happens is when when raindrops are coming through the atmosphere, which are denser and transparent medium, when sunlight is passing through it, it will be split into different colors due to dispersion, and this is the basic reason for observing the rainbows in the sky. When water molecules or water droplets are coming, when we observe at an angle of 42 degrees, we can see a full rainbow, that means in a circular path. Now, there are 2 types of rainbow. One is the primary rainbow, in which we have only 2 refractions and 1 reflection, and multiple of that we will get secondary rainbow. Now, so this is the actual situation. Sunlight is coming. When it reaches at the first entry point, it undergoes refraction, during which it undergoes dispersion and it will split into different colors, and at the surface or the boundary of the water drop and the air, it undergoes a reflection, and at the exit point it again undergoes a refraction. Therefore, we have 2 refractions and 1 reflection that produces a complete rainbow. Now, another important fact is that we know that rain is producing the rainbow, but it did not be the case. If we have a fog, especially early morning or in the late evening, and when fog means it is water droplet. So, when sunlight is allowed to pass through it, it produces the same thing. So, this is otherwise classified as a fog bow, which can be really seen during the at the location where we have waterfalls. So, this is another example of a rainbow which need not be produced by the rain, but the intensity of fog bow is always less than that of the rainbow. Now, this is the explanation. Now, here what happens is when water droplets are falling through the atmosphere and sunlight, incoming sunlight is here. So, that when we look from here, we can see that there is a chance that rainbow will vanish after some time, because when all drops are come down from our vicinity or the vision, then the rainbow will be vanished. So, it depends on the amount of rain through the atmosphere while sun is there in the sky. Now, this is a double rainbow. Double means we have primary as well as a secondary rainbow. This is a primary rainbow which is more intense, and apart from this, after a certain distance, you can see that the secondary rainbow, and there is a gap between these two. There is a dark gap between these two, and this gap is otherwise known as Alexander's band, because the emperor Alexander discovered this rainbow while he was traveling through many places to conquer different areas. Now, this is the fundamental idea. So, different if it is occurring in the late evening, the sky will be red. So, that this will be the situation. Now, actually this is the basic physics or basic science behind it. So, when sunlight or water droplets are coming down, vertically down, and the sunlight is there, then we can see the effect of the rainbow, and from which we can calculate the amount of time in which we can see the rainbow in the sky. Now, if in the morning sun is in the east, then we can see that sunlight is coming from the east, and the bow will be found in the west. But in the afternoon, if it is raining in the afternoon, then sun will be in the west, so that rainbow you can see in the east. So, in the morning and evening, the rainbow will be in different directions, in opposite directions, right. So, if the rainbow is falling, if the rainbow is observed in the evening, there is a possibility of a storm, because in the afternoon what happens is when the sun is going to set, the energy content will be stopped. As a result, the storm, there is a possibility of storm, because the land will be going to be cooled. Now, this is another optical effect which is otherwise known as a mirage. Mirage means we can, when during in a warm day, when we walk through the roads, we can see that we can feel a patch of water which is found on the surface of the road, hot road. Actually, there is no water, but it is only an image. So, here what happens is, if we have an object, that is a tree, that is in the cold condition, that is in the ground, then when light is coming from there, it comes straight. But if the ray is coming from the bottom and the top of the tree, so that when it goes through the upper layers of the atmosphere, it has to bend, because there is a temperature inversion. So, when we look at the straight, we can see that the tree will be at the top. So, actually this is another type of it's kind of an optical illusion, right. So, this is due to the refraction of light. So, this which we are observing on the road, which I have already explained. And another thing is that whenever we look at the mountains during the early morning as well as in the late evening, we can see the patch of sunlight on the top of the hill or mountain, which is mainly due to the again a mirage. So, this is considered to be another effect, which is mainly due to the refraction of light from the denser and rarer medium when it is propagating. So, actually this phenomenon, the change in refractive index causes, there is a during sunset, after sunset we can see the sun on the top in the horizon, because there is a bending of light due to the refraction. So, when we look from here on the surface of the earth, we can see the apparent position of the sun. So, even after sunrise and sunset, even after sunset we can see the sun in the sky, and even before sunrise we can see the sun due to this refraction. So, I think this is a very basic idea, basic element in which explains the optical phenomenon which is happening in the atmosphere while sunlight is passing through it. The more effects are, there are so many effects which will be discussed in the later sessions. Thank you.